Okay, a battery of EMF 42 volts and internal resistance 7 ohms is used to supply a circuit. There are 3 resistors in parallel, and the values here 2, 4, and 8. 3 resistors, 2, 4, 8 ohms. So 2, 4, 8 ohms in parallel. So they are in parallel. Now, if the current is switched on for 30 minutes, find the quantity of electricity which would have been conveyed. So, let us say this is our battery, and this is our internal resistance. So, this is the battery here, and this is supplied to a resistors of parallel. So there's a parallel here. 1, 2, 3. So this is a parallel. 2, 4, and 8 ohms. So this is 2 ohms, and this is 4 ohms, and this is 8 ohms. So this is 42 volts and 7 ohms internal resistance. So what is the quantity here? Let's say there's a switch, and the time here is for 30 minutes. Okay, so what is the quantity here? This is of course the current flowing here. The current. So how much quantity is being conveyed by this circuit? So remember, the formula of quantity is I times the time. Current times the time. So we need to know what is the current flowing here. The current flowing here in this circuit is to determine first the total resistance here. Okay, so that we can compute the current. The total resistance here is this one, the parallel. We need to combine this. Let's say the equivalent, then we later on combine the 7 ohms internal resistance. Okay, so compute first this equivalent resistance. So let us actually there are formulas that we can compute the total resistance. Let us use this R equivalent. We can use this formula 1 over 1/2 plus 1/4 plus 1/8. You can use this formula. Okay, and you can also use this formula if you like. 1 R equivalent is equal to 1/2 plus 1/4 plus 1/8. You can also use this formula, or you can use this formula R equivalent equals to 2 times 4 times 8 divided by 2 times 4 plus 4 times 8 plus 2 times 8. You can also use this formula. So let us try to use this formula. I think this is much easier. 2 times 4 is 8 times 8 is 64. 2 times 4 is 8. 4 times 8 is 32. 2 times 8 is 16. Okay, so what is this? 8, 32, 40, 56. So 64 divided by 56, 1.143. Okay, so this is 1.143 ohms. That is the R equivalent. Okay, so R equivalent 1.143 ohms. Now to get the total resistance of the circuit, we simply add the internal resistance plus the equivalent. Okay, so the internal is 7 ohms plus the equivalent is 1.143. This is 8.143 ohms. That is our R total. To compute now the current flowing here is current equals to the voltage divided by the resistance. The voltage is 42 volts divided by the resistance of 8.143. 42 divided by 8.143 is equal to 5.16. Okay? So 5.16. So 5.16 amperes flowing there, your eye. Okay, we can compute now the quantity. Q is I times time. So I is 5.16 amperes times the time must be in terms of seconds. So since the given is 30 minutes, I think this is also equal to times 60, 1,800 seconds. 1 minute is 60 seconds. So we just multiply it by 60 to make it in seconds. So this is 1,800. So this is 1,800 seconds. So if we multiply this, 5.16 times 1,800, 9288. So this will give us 9,288 ampere second. Or this is equivalent to 9,288 coulomb. Or this will give us also, will divide it seconds to hour is 3,600. So we'll divide this by 3,600 is 2.58 ampere hour. This is also equivalent to 2.58 ampere hour AH. So we need to say 2.38 amperes in an hour, so that you can consume the quantity. Okay, so that is how we solve involving quantity.